All right, so, excuse me, Chapter 8, Section 1 is called Sequence and Series. Okay, we're going to cover just that. You're going to learn how to figure out the terms in a sequence or series, and then you're going to learn at the end how to, like, find the summation of a sequence. So we start with what is a sequence. There are two types, infinite and finite. An infinite sequence is a function whose domain is the set of all positive integers. So you're going to see that there's a variable. You're going to take and you're going to start with 1 and you're going to continue to plug in until it tells you to stop, would be the idea of a series or sequence, sorry. If it is finite, it means there's a set number, like the first 5 terms or the first 6 terms. If it's infinite, it goes on forever, okay? We will mostly focus on finite sequences where it will tell you like that find a certain number of terms in the sequence. And it says positive integers, meaning that when we plug in, we're not plugging in for like fractions or decimals. We'll plug in, 1 and 2 and 3 and 4 and 5 and positive integers. So starting with all, they would all be positives. The names of these terms are going to look like this. So A with the little one, A sub 1 is the first term in the sequence. A2 is the second term in the sequence. A3 is the third term, A4, and so on and so forth. N represents the last term in the sequence. So if there's 6 terms in a sequence, then N is 6. So this starts with just basic plugging in. It says write the first 4 terms of the sequence, and we assume, unless it tells us otherwise from here on out, we will assume N begins with 1. So if A is 2N minus 4, then I'm going to find A1, I'm going to find A2, I'm going to find A3, what did we say? 4. And I'm going to find A4, and I just take and plug those numbers in. So 2 times 1 minus 4, 2 times 2 minus 4, 2 times 3 minus 4, and 2 times 4 minus 4. So 2 minus 4 is negative 2, 4 minus 4 is 0, 6 minus 4 is 2, 8 minus 4 is 4. So when it asks you to write the first 4 terms of the sequence, you will list them in the order that you got them, negative 2, 0, 2, and 4. B, same type of question, different kind of expression. So it says A sub n equals 2n over n plus 1. We do the same thing. We're going to find A1, we're going to find A2, we're going to find A3, and we're going to find A4. So this would be 2 times 1 over 1 times 1 plus 1, sorry. 2 times 2 over 2 plus 1. 2 times 3 over 3 plus 1, and then 2 times 4 over 4 plus 1. So I'd get 2 over 2, which is 1. 4 over 3 is going to stay as 4/3. You can rewrite it as 1/3, but you don't need to. 6 over 4 gets simplified to 3/2. And 8 over 5 stays as 8 over 5. And then we list them in order that we got them: 1, 4/3, 3/2, and 8/5. So you don't like rearrange them in value order ever. You just get them in the order. Not that it would change that one, but you would just put them in the order in which you got them. Good so far. Easy stuff, right? Just plug them in. All right. This one says write the first 5 terms of the sequence. So that number is going to change. You want to make sure you pay attention to it in the instructions. And again, a little bit more like complicated. There's 3 n's this time, so we're plugging in that number in 3 times. So I'm still doing the same thing. A1, A2, A3, A4, A5. This would be negative 1 to the first over 1 times 1 over 1 plus 1. Negative 1 to the second over 2, times 2 over 2 plus 1. Negative 1 to the third times 3 over 3 plus 1. And negative 1 to the fourth times 4 over 4 plus 1. And negative 1 to the fifth times 5 over 5 plus 1. So my -1 to the first is going to stay negative, and then I get 1 over 2, so this is -1/2. -1 squared becomes +1 times 2 over 3, and that's +2/3. -1 to the third, -1 times 3 over 4, so -3/4. -1 to the fourth, so +1 times 4/5. And -1 to the fifth, -1 times 5/6, -5/6. And then we list them in the order we got them: -1/2, 2/3, -3/4, 4/5, and -5/6. So eventually we're going to have an actual series, and you're going to try to figure out what that equation would be to get you to that point. So start to pay attention to the things that we're doing with these numbers, right? 1, you could have n in multiple spots. It doesn't have to just be one spot. You could put it in a fraction where you're altering the number in a different way in the top and the bottom. And you could also be raising -1 to an end power. And what that does is alternate your signs. So if it's -1 to the n, that would give me a negative at first, and then it would give me a positive, and then it would give me a negative, and then it would give me a positive. So that's how you would alternate signs if you saw that in a sequence. Still good? Yes? Okay. All right. Now you can jump to any one in that block. So this says find the indicated term of the sequence, and it's giving you the a sub n, and it's asking you to find the fourth term. So I go directly to 4. So A4 would be 4 squared over 2 times 4 plus 1, which is 16 over 8 plus 1, 16 over 9. And you leave it just like that. So I could do multiple terms in a sequence, or I could jump directly to one specific one, and that's how it would look. Still good, right? Yeah. Good morning. So it says write an expression for the apparent nth term of the sequence, assuming n begins with 1. So we have to say a sub n equals, and we have to figure out what that pattern is. Now what people try to do, which is wrong, is look from one term to the next, to the next, to the next, and try to find a pattern within these, okay? That's not what you're doing. You're saying A1 would be 0, A2 would be 3, A3 would be 8, A4 would be 15, and A5 would be 24. So the pattern you have to find is the relationship between the 1 and the 0, and the 2 and the 3, and the 3 and the 8, and the 4 and the 15, and the 5 and the 24. So it's not from the one number to the next like a pattern, okay? We'll get to those. Those are arithmetic sequences, but we'll get to those in the next section. So what could we do with n that gets us from 1 to 0, 2 to 3, 3 to 8, 4 to 15, and 5 to 24, but it has to be the same thing every time? I'll let you stare at it and see if you can figure it out. Okay, let's try it. So 2n minus 1 would be 2 times 1 minus 1. That's 2 minus 1, which is 1. So it doesn't work for the first one, right? What else could we get? Oh, sorry, Grayson. N squared minus 1, n squared minus 1. So this would be 1 squared minus 1. That's 1 minus 1, which is 0. 2 squared minus 1. That's 4 minus 1, which is 3. Still working. 3 squared minus 1. That's 9 minus 1, which is 8. 4 squared minus 1. 15 minus 1, which is 16 minus 1, which is 15. And 5 squared minus 1, 25 minus 1, which is 24. So it works for all of them. Good job. Okay. Sometimes there is more than one answer. I think for that one there's not, but there sometimes could be more than one answer. So just because you get yours differently doesn't mean it's wrong. And I would say a trick is kind of look at the difference between the beginning and the end. First of all, look and see, are there fractions involved? Does the sign change? That kind of stuff. But also think that there's a much bigger gap between the 1 and the 0 than there is at the end in the 5 and the 24. If there's a big gap there, then it's probably not multiplication. That's where an exponent can get involved. An exponent can help you kind of jump a significant amount of steps without that big of a change. So keep those kinds of things in mind. But again, it's not always going to be that simple. Sometimes you got to look at it a little bit. All right, now look at B. N plus 1 over n plus 2. So let's see. A1, A2, A3, A4, A5. This one's 2/3. So we're saying 1 plus 1 over 1 plus 2. 2/3, that works. This one's 3/4. 2 plus 1 over 2 plus 2. 3/4. That works. This one's 4/5. 3 plus 1 over 3 plus 2. 4/5. This one should be 5/6. 4 plus 1 over 4 plus 2. 5/6. And the last one, 6/7. 5 plus 1 over 5 plus 2. 6/7. So that works. And this would be A sub n equals n plus 1 over n plus 2. Good job. Questions on those? Okay, there are a special kind of sequences, and they are called, well, eventually we're going to get to arithmetic and geometric, but for right now we're going to start with recursive. So recursive sequences mean that there is something based on the previous term involved. So I need to know A1 to get to A2, A2 to get to A3, A3 to get to A4, and so on and so forth, okay? It just means it relies on the one before it. So this is where, okay, so it says a recursive sequence is one that relies on the value of the previous term. To define a sequence recursively, you need to be given one or two of the first two terms. So you can't find the terms in a recursive without giving it a starting point. Whereas before I gave you an equation and I said find A1, I could say find A5, whatever it is. Recursive, they have to give you something. So the little notation, I think it looks more confusing than it is. This would be like, let's say this is my first term. Every term after that is the term before it, which is what this means. AK would come before AK plus 1, right? If this was A2, then this would be A1 plus 10. So it's saying take the term that comes before it and add 10 to it. So if I know A1 is 5, that is my first term. A2 is the term that comes before it, which would be A1 plus 5. A3 would be A2 plus, not 5, sorry, 10. I don't know why I put 10. 10. A4 would be A3 plus 10. It's always take the number that comes before it, and then in this case, add 10 to it. So if A1 is 5, then this is 5 plus 10, which is 15. If A3 is A2 plus 10, then it's 15 plus 10, which is 25. A4 is the one that comes before it, 25 plus 10, which is 35. So these have a pattern between their steps. Each one is 10 more than the one that came before it. The ones that we just did don't necessarily have to have a pattern like that, but recursive will. Recursive will always take the one that comes before it and do something with it. Doesn't mean you're always adding 10. Sometimes you're times by 2, so you're doubling each one as you go. So example 5 says, write the first 5 terms of the sequence defined recursively. So I've got, again, has to give you somewhere to start from. I get A1 is 15. So then A2 would be A1 plus 3. So this would be 15 plus 3, which is 18. A3 is A2 plus 3, which is 18 plus 3, or 21. A4 is A3 plus 3, or 21 plus 3, which is 24. And A5 would be A4 plus 3, or 24 plus 3, which is 27. So each time you're taking the one that comes before it. So when it says write the first 5 terms, we're going to write them out in the order we received them, and we had A1 given to you. So A1 has to be part of your recursive series, and I would say that's probably what people miss the most if they're going to get this question wrong, like on a quiz or a test. They forget the first one. So 15, 18, 21, 24, and 27 would be the first 5 terms of the recursive sequence. Still good. Yes. All right, example 6. Write the first 5 terms of the sequence defined recursively, and then use the pattern to write the nth term of the sequence as a function of n. So the first part is the same thing we just did, okay? This time we're multiplying by a third each time. So A1 is 81. A2 would be 1/3 times 81, which is 27. A3 would be 1/3 times 27, which is 9. A4 would be 1/3 times 9, which is 3. A5 would be 1/3 times 3, which is 1. So step 1 is the first 5 terms. Now step 2 says go back to what we were doing before and figure out a way to find the pattern without using a recursive system. So if A1 is 81 and A2 is 27 and A3 is 9 and A4 is 3 and A5 is 1, find the relationship between the term, the number term, and the value. Try it. Why?
Would it be n divided by 3?
So n divided by 3, and this one would be 1/3, right? So if you, like what base would give you something raised to power would end up being 1, 3, 9, 27, and 81. 3, okay. We're getting warmer. Work with 3. Can I do 3 to the n? No, 3 to the first would give me 3. 3 to the second would give me 9. It's working in the other direction. Say it again. 3 to the n minus 5, like that?
Yeah.
Try it. So 3 to the 1 minus 5 would be 3 to the negative 4. So the only problem with that is it is 81, but it's 1 over 81, right? Divide by n like this? No, we need to move it. How do you move a base? How do I make a 1 over 81 become 81? Okay, so let's try that. We need to flip the sign, right? Because a negative exponent is actually going to move that up. My eraser. So we're saying instead of making it n minus 5, make it 3 to the 5 minus n. So this would be 3 to the 5 minus 1, and that's 3 to the 4th, that's 81. 3 to the 5 minus 2, that's 3 to the 3rd, that's 27. 3 to the 5 minus 3, that's 3 to the 2nd, that's 9. 3 to the 5 minus 4, that's 3 to the 1st, which is 3. And 3 to the 5 minus 5, which is 3 to the 0, and that's 1. Good job. You could have also, like I've seen in the past, people use base of 1/3, and then you can flip it. So if you did a base of 1/3, you can do n minus 5, and the 3 will be in the bottom to start with, and it will also work that way. So something like that would also work, 1/3 to the n minus 5, okay? So that's what I was saying before. Sometimes you're going to get more than one answer. Try to find the commonality between what's happening on the left and the right. If they're getting smaller, obviously you need to figure a way to make it smaller. And if it's a significant jump, like from 81 to 27 to 9 to 3 to 1, I tend to look for the things like a 1. Like, how am I going to get something raised to a power to a 1? Right? I need that power to be 0, and how could I make that power 0 if it starts at 5? So sometimes little things like that, little tricks like that will help you try to figure it out. Questions on that one? All right. Oh, sorry. So factorial notation is something that 1, standardized tests will actually use. 2, you haven't seen it probably since middle school. But it is an exclamation mark, okay? An exclamation mark does not mean you're excited and you're yelling that number. Not like 3. That's not what factorial means. That means take that number and multiply it times a term less than it until you hit 1. So if I have n to the first, it would be whatever n, it's going to start with the highest power of n and work its way down till you hit 1. I would actually reverse the order, like this is the definition of it, but I would reverse the order. I go highest down to 1 instead of 1 up to the number. So if I'm doing 5 factorial, this is 5 times 4 times 3 times 2 times 1. And you multiply all those numbers out, okay? If it was 6 factorial, it's 6 times 5 times 4 times 3 times 2 times 1, okay? So a large number, obviously, you would have, like if it's a big number, you would have a calculator for something smaller like that. Well, and we're also going to show you how to simplify with it. But you can also, you would have a calculator. Some calculators have a factorial button. Most of the scientific calculators have a factorial button under the probability button. So if you want to take out, if you have a calculator with you, I'll show you where this is. On the scientific calculator, there's a button that says PRB, okay? A lot of what we're going to do this chapter lives in that menu. You'll see the little exclamation mark, it's right there. So if I wanted to do 5 factorial, let's just say, I would do 5 PRB, arrow over to that, and hit enter, and it's 120, okay? If my calculator doesn't have it, then I would do 5 times 4 times 3 times 2. You could put the 1, but it doesn't change anything. Hit enter, and you get the 120. On the graphing utility, it's under math, and then you arrow over to PROB. There's your probability, and it's the 4th thing in the list. So if I wanted to do 5 factorial, I do 5 math, arrow over to probability, and 4th thing in the list is my is my exclamation mark, and again, I'd get the same answer. So some of these are going to be small, and you'd be expected to do it without a calculator, and then some of them will be a little bit larger. One of the things you cannot do, because you can't break it down, is 0 factorial. 0 factorial is just 1. So the answer to that is just 1. If you see it, like there's no way to figure that out. You can't mathematically compute it. Your calculator can, but your brain can't because there's nothing to work out. That is just 1. All right, so if I did A, which is 5 over 7 factorial, if you wrote it all the way out, it would be 5 times 4 times 3 times 2 times 1 over 7 times 6 times 5 times 4 times 3 times 2 times 1. Would you want to multiply all that out and then try to find, no, common denominator, right, and then cancel it out? So what you can do is I would know both 1s are going to cancel. I would know both 2s are going to cancel. I would know both 3s, both 4s, and both 5s. So what's left in the top? 1. What's left in the bottom? 7 times 6, which is 42. You're welcome. You're welcome, Amalia. I'll see you later. Yes, ma'am. So here's a quicker trick. Look at the two numbers and take the bigger number, break it down till you hit the smaller number. So I'm going to keep 5 as 5 factorial in the top. And then in the bottom, I'm going to rewrite it as 7 times 6 times 5 factorial instead of writing all of that out. And then you can literally cancel out the 5 factorials and you'd get 1 over 42. So if you've got a fraction, right, and whichever one is bigger, you want to break down until you get to the smaller one, and then those will cancel out. Sometimes they're going to cancel leaving you with the 1 in the top. Sometimes they're going to cancel leaving you with the 1 in the bottom. It just depends on where the factorial is bigger, okay? All right, so think about that, and now go to B. What's bigger, n plus 2 or n? N plus 2. So I'm going to break n plus 2 down until I hit the smaller one. So what would be 1 less than n plus 2? N plus 1. What would be 1 less than n plus 1? N. And then I've hit the smaller one, right? Put that over the n factorial. Those are going to cancel. And then my answer would be n plus 2 times n plus 1. If you FOIL that out, you'd get n squared plus n plus 2n plus 2. N squared plus 3n plus 2. So quiz or test, I would take either of those answers. I will look at WebAssign, and because I don't remember that format. So for this answer in WebAssign, either of them work. Save yourself the trouble, keep it as it is. But either of them will work. It'll take either type of answer, okay? All right, then the last thing in this section is called summation notation. So this little like weird E is summation. It is known as sigma. That's the name of it. There's another little Greek letter for you, some good college prep, okay? That is called sigma, and it means find the sum of the terms given. So you would start with the term on the number on the bottom. If it looked like E and it said I equals 1 and the top number was 3, let's say, this means find A1, find A2, find A3, and then add them all together at the end. If the bottom number was 1 and the top number was 5, now I would find A1, A2, A3, A4, A5, and then I would add them all together at the end, okay? If the bottom number changes and it doesn't start with 1 anymore, then I start with that number and I still stop at the 5th term. So I would find A2, I would find A3, I would find A4, and I would find A5, and then I would add them all together.
If it doesn't say what I is, we just assume it's 1?
It will always give you something on the bottom for summation. But yeah, sure. And in general, if it doesn't tell you where it starts, it's 1. But summation notation will always give you a starting point. Good question. So example 9 says find the sum, and it says the sigma, right? So at the top it is 3, at the bottom it is 0. So this time I'm going to find A0, A1, A2, and A3, always stopping at the top number. And then I'm going to add them all together at the end. So 0 plus 1 times 0 minus 2, which is 1 times negative 2, negative 2. Then 1 plus 1 and 1 minus 2, 2 times negative 1, negative 2 again. 2 plus 1 times 2 minus 2, 3 times 0, which is 0. And 3 plus 1 times 3 minus 2, 4 times 1, which is 4. Now, those are the terms in the sequence. We are finding the sum of them. That's what that E means, so I have to add these together at the end. Negative 2 and negative 2 is negative 4, plus 0 stays negative 4, plus 4 becomes 0. So the summation of that series, or that sequence, is 0. Sometimes you're going to get fractions in here. Sometimes they're positive. Sometimes they're negative. Sometimes there's a pattern to them. Sometimes there's not. But you're always starting with n being the bottom term, and then you're stopping with it being the top term. Questions? So eventually we're going to learn shortcuts to do certain kinds of sequences with that, like in A2, it's an arithmetic sequence. But for now, you're plugging in and you're adding them no matter what kind of term they are.